All right, so guys, today we're doing lesson 11.3, and it is a lesson that I think all of you can get really well. But I'm going to scroll down to the bottom of the page, and so go on the back side of this. And I want you guys to see if you're logically. Now, obviously in my last class period, I sit there and wrote it on the whiteboard. But since we're recording this, I'm going to put it on here. But I have a question for you. I want to see what you know. All right, what you know. I'm going to give you a circle. And in that circle, I'm going to give you a central angle. And I'm going to shade the middle of this. I'm going to give the radius of the circle, let's say is 8 inches. And the arc measure that it hits, it intercepts is the wording for it, is 40 degrees. I want to know the area of that green piece. I want to know the area of that. What do we know? What tools in our tool chest do we have that will help us solve for the area of this? You know, the kind of like that piece of pizza looking piece, all right? Or a piece of pie if you like that better, okay? What would you do? What?
The cord.
The cord? Maybe, but if you draw the cord, you're gonna cut off part of it, right? So, but that's not a bad idea. Good thought process, because I'd rather you do that and not try it all. Keenan. So using maybe like the area of a semicircle. Okay, let's go back there. How would you find the area of a semicircle?
1/2 square.
How did you get the 1/2? It's half a circle. Okay, so it's a fraction of a circle.
So we can find out how much 40 degrees goes into 360. And you do that fraction times 1/2 square.
Great. Don't I just need to know what fraction of the circle I used? And what's one thing we know? All the way around a circle is how many degrees? So wouldn't the arc give me that fraction? So really, I could literally go 40 over 360 gives me what fraction of the circle is being used times, well, what's the one thing we know? Area of the circle, right? Don't we know what the circle's area is? Isn't it a fraction of the circle's area? So it'd be pi. What are we going to have? Let's go, I should have put pi r squared here first. Hold on, I'm going to do it here. So we're going to put 8 squared, right? So that's going to be what? 1/9 times, what's that, 64 pi? So 64 pi over 9. Label that because it's area, square inches. So I just need to find the fraction of my circle. Well, we've got a tool now to do that. That's really easy. The degree measure of your arc. Or the degree measure of the central angle. I mean, it's the same thing. We know that. That's all it is. Now, that has a special name. This is called the sector of a circle. Think about it. If you ever, or if you're a sci-fi person and you've listened to any Star Trek, whatever, they talk about the different parts of the universe as sectors. So think about it. It's like a portion of it, right? So when I have a sector of a circle, it is the following things. It is a region bounded by 2 radii of a circle and their intercepted arc. Gentlemen, are you done talking and you're going to write things down? Yeah. Thank you. Good choice. So basically, it's the piece of pie, okay, or the slice of pizza, if it's a round pizza, that you would have. And notice how they name a sector. They name it with the 3 points, so the endpoints of the arc and the vertex of the circle. So if they name a sector, be careful that you use correct notation. Notice there is no shortcut. You write out the word, get this, sector. Ooh, I know. So make sure you have it down. But the area formula, you guys already know. It's the degree measure of the arc over 360. It's the fraction of my circle times the area of a circle. So times pi r squared. If you look at your book, they do it differently than me. This is the better way. I always think of it as what fraction of the circle do I have? Now, just a hint that was given to you from the textbook and stuff, if you don't do this, it's not the end of the world. But when you're working with it, if you put the degree symbol with the M, you remember you're looking for the degree measure of the arc, not its physical length. So just remember M, if you see it, think degree symbols. Because we use M also for what value? Slope, right? So you just want to make sure you're using the right thing with it. All right, so let's do this real quick. Guys, I have a feeling you're going to want your calculators out because most of you don't like fractions, and there's going to be lots of fractions for answers with this. So make sure your calculators are out. But what's the one thing I need to do for this? It says find the area of sector HGJ. So that means I know I'm looking at this one right here. You always write down what? Always write down your formula. That hasn't changed from chapter 9 or chapter 10 or whatever. If I have an area formula of any sort, I'm always going to write it down. So it's going to be obviously m over 360 times pi r squared. Now, then you just ask yourself, plug and chug in what you know. What's m in this case, guys? 131 over 360. Now, I'm going to put this over 1 because I know I'm working with fractions. So I got pi, my radius squared, well, that's going to be 12 squared. By the way, that's a typo. There should be a space between the 12 and the m. And then you just do some simplifying real quick. And this is what you can do on your calculator. Now, what's the one thing, if I want it in terms of pi, what can I not put in my calculator? The pi, right? But could I put this in your calculator? You should see something like this. Using your alpha y equals, put in a fraction, and you should have had 131, 144 on top, and shouldn't you have 360 on the bottom? You put it in the fraction format to start with. When you do that, when you hit enter, you should get an improper fraction, correct, guys?
Yeah.
What was your improper fraction? So 262. What am I going to put there so I don't forget it? Pi over 5, and that would be in square meters. So that's the exact form. Anyone like the exact form? But it also said to the nearest hundredth. Guys, how many decimal places is that? Take what was in your calculator and multiply it times pi this time. So take that fraction and go times pi, you're going to get your value. What'd you guys get? All right, careful. To the hundredth. How many spots if it says hundredth, guys? 6.2, and that'd be square meters. So make sure that you're using both of those. Guys, I prefer, and you guys know this, exact. Your book asks for both. Now, before I forget, on 16 through 18, the book says to go decimal. I don't want decimal answers. I want exact answers. Okay, so just for 16 through 18, those 3 problems, give me exact answers. It says on the calendar, but just quick review. Make sure on the homeworks you do that. All right, guys, go ahead and do the next one for me. Just go ahead and crank it out for me. Use your formula. Plug and chug what you know. But again, if I walk around right now, I better see everyone have a formula down, right? Correct?
Yeah.
All right. What do you think equals in here? You're doing a cross multiplying problem also. Don't do that. Make sure you use parentheses instead. I'm looking at yours. Is there a formula?
No, I just heard it. I didn't do anything in my calculator.
Guys, when you punch that into your calculator, what'd you get for your fraction? What'd you get? I got 125 pi over 72. Double check what you put in your calculator. Over 72, and I got that to be square feet. That's my exact form in terms of pi.
Oh, yeah.
Did you punch something in wrong?
I did 25 times 25 as 50 instead of 200.
That would be, yeah, that'd be 6, yeah.
Yeah.
It's a lot bigger number than what you got, yes. All right, guys, what do you get for decimal? It's 5 what?
0.5.
Yep, 5.45 square feet. Because again, it said to the nearest hundredth. I want both of those answers. All right, I think we're pretty good. Do we need to do another one of these? All right, so if you want to see this, it's where? It's your filled in notes online. All right, I'm going to give you the answer for those of you who started this without permission. All right, the answer on this would be 128 pi over 5 square inches, and approximately it'd be about 80.5 0.42 square inches. But work is in the notes online. What's one thing that I'm gonna ask you to do every single time? Write your what? I will take off 10 percentage points on your completion grade if I don't see formulas. Did everyone hear that? All right, I will always do that. It's one of those things, you gotta learn to show your work, and you do better when you do. All right, now the windshield wiper problem. The reason why I like this one, they're trying to give, actually debate with this problem, the people wrote, I got from the authors of the book. It says a windshield wiper blade is 18 inches long. To the nearest inch, what is the area covered by the blade as it rotates through an angle of 120 degrees? So like on your windshield, you have your blade, and it would literally go back and forth 122 degrees is basically what they're saying. Now, here's where I have a debate in my head. They want the simple sector here, as if your blade would go all the way around in a giant circle, correct? Does anyone see a problem with this as the example that they gave? Your blade, doesn't your blade stop about right there? Right? Doesn't it miss that, like that little, almost another little sector, right? Like it misses a sector of a circle there. So we're gonna go with the idealness of this question, but could you see where I and the authors of the textbook, I'm like, you should be looking for that. Almost like concentric circles, sector minus sector type problem. Do you see me like Charlie? Yeah, but the problem is they didn't give me enough other information that I can do it that way. But that's really in the real world would be more like the area it covers, right? But we're gonna go with what they did. The example, we're like, okay, it's a perfect blade and it goes right there. We're gonna use that, but it's really not quite true, especially if you've ever driven a car. You guys know it doesn't cover everything like they say it would. All right, so with this one, can we just plug and chug it into our formulas again? Yeah, so we get our area equals m over 360, so m degrees times our area. And again, guys, the reason why I put everything over 1 is I want to remember when you multiply fractions, numerators multiply together, and what multiplies together? Denominators do. So it's one of those things that's just easy to keep the habit going. So here we're going to get 122 over 360 times pi times 18 squared. Since that's not a fraction, I'll put it over 1. What did you guys get when you simplify that one down on your calculator? All right, good. 549 pi over 5. And you guys got square inches? Awesome. Now, anyone starting to really like their fraction key on their calculator today so far? It's a time saver. You know you can simplify these more on your own. It just takes a lot longer, right? So what did you guys get for your approximate answer to the nearest hundredth, I think, right? No, nearest square inch. Oh, this is the nearest square inch. So no decimal, right? So this should be 345 square inches. Yep, to the nearest square inch. Are you guys good with that? All right. The next thing, I didn't do this, and I needed to. Guys, this is supposed to be shaded right here. So if you can just shade it in with your pencil or pen. All right. Do you remember yesterday, some of you, I don't know if it was yesterday or Wednesday, some of you were like, oh, that's like a segment of it. And I'm like, don't use that word with circles because this is the case. A segment of a circle, so you have to be very careful with its terminology, is a region bounded by its arc and its chord. So basically, it's like the pizza crust of your slice of pizza. Okay, so it's like I took a sector, and then what did I remove from that sector? The triangle, right? So I literally took away the triangle. Well, just remember that triangle is always isosceles triangle, if nothing else, right? So I call it the pizza crust. It's just the crust. It's the very little area that's there. That name is called a segment. So I will be asking you to solve for the segments of circles. Now, here's the thing. There's no fancy formula. It's all about the process. If I hadn't told you that was a segment of a circle, could you guys found a way to solve for the area of that? What would you guys done? Ethan, what would you done?
Find the area of the sector and then subtract the area of the triangle.
Exactly. Look what your next page says to do. How do you find the area of a segment of a circle? Area of the sector minus the area of the triangle. That's how you do it. Every single time. So the process is that you have basically two area formulas you have to use, but isn't it just a subtraction problem? It's like is really what it is. So heads up on this. The next 3 examples are what I like to do with these. These have been known to show up on quizzes, like near future quizzes, test as well. But these are huge that you know how to do. So on this first one, it says, find the area of the segment LNM. Notice they still name the vertex for this when they're talking about segments of circles, because they want you to understand exactly where it's located. Now, we said it was a process, so could we at least go ahead and solve for the 2 different parts? So here, can I find the area of the sector first, right? So we are getting pretty good at that, so we get m degrees over 360 times pi r squared. So I'm going to go 120 over 360, because it's the degree measure of my arc, times my radius, which is going to be 9 squared. I'm going to put that over 1. Guys, that's 1/3 of 81 pi, which is 27 pi. So the area of the sector is 27 pi square centimeters. Now, that's if it was all filled in, right? I have to subtract what? The triangle. But that triangle is an obtuse triangle. But it's also what type of triangle? Isosceles. So can I redraw it over here so it looks something like this? 9, 9, that's 120. How do I find the area of a triangle? Base times height over 2, or I'm going to tell you right now, the better one to use is 1/2 base times height on this one. But what's missing here? The height and my what? I'm missing my base too. So if that's the case, can't I draw one in? Because I know that's an isosceles triangle. So if I draw in the perpendicular segment from the vertex angle, what does it do to the base? Bisects the base. And what does it do to the vertex angle? Yeah, so this would be a 60. Isn't that just become a 30, 60, 90? Let's see if I can get that a little bit better here. Correct? All right, now here's the key thing. Don't put them in the wrong spot. Your short leg has to go in the short leg location. How do I go from hypotenuse to short leg? So doesn't this one become 9/2? That's short leg. How do you get to the long leg? So I get 9√3/2, and I get 9√3/2. So basically, what does that add together to be? 9√3, right? Because 9 plus 9 is 18. 18 divided by 2 is what, guys? 9. So I get 9√3. So the base of my triangle is 9√3. The height of my triangle is 9/2. So I got to go 1/2 my base, which is 9√3, and I'm going to put that over 1 because I know I'm working with fractions, times my height, which is 9/2. That gives me 81√3/2. Not impossible, but you have to remember stuff about isosceles triangles, 30, 60, 90 triangles, and area formulas. So 3 different chapters are coming together for one thing. So when we do that, what's the area of the segment? Well, it's the sector minus the area of the triangle. And that means square centimeters. That's one of your answers, but it also said to the nearest what? Said to the nearest hundredth. So what are you going to get to the nearest hundredth? That should be punched into your calculator.
14.6.
What'd you get?
Good question. Isn't that 81/3? Yeah.
Oh, thank you. Good save. Oh, I'm so proud of you guys. Way to catch it before we totally got the problem done. Great job. No, you're not getting brownies on this one. I still owe you other brownies. No.
49.75.
Thank you. Nice. Ice cream, really? Be happy brownies come once in a while, okay? Just be happy they come, all right? And I must make those last batch of brownies, all 5 that I did last week, turned out good. All right. I enjoyed every single one of them. Great. So I'm 5 pounds heavier. But anyway, makes sense? Let's do another one. All right, so find the area of the segment RST in exact form and to the nearest hundred. Now, this one should make you happy when you see this one. Guys, what's the degree measure of my arc? 90. All right, so it's actually a nice number for once, right? So let's do the process. Area of sector minus area of triangle. So let's find the area of the sector first. And notice I literally write down area subscript sector, so I know which one I'm working with. So I got m degrees over 360 times pi radius squared. So I get 90 over 360. What's our radius in this case, guys? So I get pi times 4 squared. I put that over 1 because it's not a fraction and I have a fraction. Guys, what's 90 over 360 simplify down to? No, this one should be on your head. 1/4. All right, so 1/4 times 16 pi. You should be able to tell me what this is without a calculator. It's 4 what? 4 pi. Excellent. So that'd be 4 pi square meters. What's my area of the triangle, though? What formula am I going to use? 1/2 base times height or base times height over 2. I'm going to use base times height over 2, but 1/2 base times height, aka same thing, both works. All right. What's my base of that triangle? Okay. What's the height of that triangle? Why did you guys pick 4 and 4 to be my base and my height? What type of triangle is it? What else? What type of triangle? If it's a right triangle, what do you use for base and height? The legs. Yeah, you use the legs. You don't have to sit there and try to calculate anything else. If you have any right triangle, as long as you have the leg lengths, you can find its area that way. So that would end up being 8, correct? When you're working with it. So it'd be square meters. So what's the area of the segment? That's going to be 4 pi minus 8 square meters. And you also need to give me a decimal here on this one to the nearest 100. No, 100. All right. I will count it wrong if you do that. Like, guys, if you give it to me the nearest, let's say the nearest square meter, and it said go to nearest 10, it's wrong. You didn't follow directions. You're not giving it exact as they want you to give it. So make sure you're being careful. All right. What do you guys think? Easy? All right. You guys want to try the next one?
Yes.
All right. Try the next one. I have a feeling there's not going to be a problem finding the sector, the sector area. Segment, maybe a little bit more, but sector, not an issue. That's not going to be 6 and 6. Well, I guess you could do it that way. I don't know why I need to. Yes, excuse me, it would be 6 and 6. You can do it that way. Never mind. I would have used a total different formula. Oh, yeah. Guys, what type of triangle is that? It's what?
36.
No, careful. What type of triangle is that? Equilateral. Because if the vertex angle of an isosceles triangle is 60 degrees, what do the base angles have to be? 60. So could I use side squared root 3 over 4? Now, a few people redrew the triangle and used 30/60 that way. That's great. You're going to get the right answer as well if you don't mess up. So you got 12 squared root 3 over 4. Did you guys get 36 root 3? All right. Nikki, did you get 36 root 3 on yours?
Yeah.
Good. Excellent. All right. So what's the shaded area in exact form? So the shaded area, which is the segment, is going to be the sector, 24 pi, minus the triangle, which is 36 root 3 square inches. That's exact form. That's how I want 16 through 18 done on your homework. You guys with me on that? All right. Wonderful. Let's do one last thing, because I think this would be common sense. I had a grandparent there at Grandparents' Day when I was teaching you about minor arcs, major arcs, and semicircles. He got very upset because I didn't do this with you. okay? He goes, you are gonna teach them circumference, aren't you? And I'm like, I already taught them circumference, we're fine. I go, they will get this all put together, I promise. So this is a Grandparents' Day thing that I was gonna do anyway. Okay, so the thing is, we talked about on Grandparents' Day, when you look at two different circles, and they both had the same degree measure, are they congruent arcs? No. What makes arcs congruent? Exactly. The radiuses have to be the same. The radii have to be the same in order for that to happen. Well, that's because of circumference, correct? So the physical length. Now think about what we've been doing. If I want to know the length of this arc, how would I find it?
Percentage of the circumference.
It's going to be the fraction, or the fraction of the circumference. How do I get the fraction of the circumference? Can I use the degree measure or the central angle? Like, either way, it's the same thing, right? So the fact is, I'm just doing a fraction of the circumference. Exact same thing as we did for area. It's a fraction of the area. We're going to do fraction of the circumference. So the formula, I use L. I use a lowercase l. I think your book uses a capital L. I like mine better. At least L means length. All right, and I don't like using capital L because it's LA is lateral area, so that type of scenario. But it's just the fraction of the circle, so m degrees over 360 times the circumference. If you wanted to, would this be a valid formula? What does C stand for? Circumference. So if you had a diameter one, could you do that? That would help. But really, if you know how to do area of a sector and area of a segment, this should be like a walk in the park. Here's the only problem. People label it wrong. Because they've been doing area all the time, all of a sudden they'll like, oh, the length is squared. When did the length become squared, right? So be careful to make sure you know what you're looking for. Sound valid? All right, let's crank out some problems. I'm not going to waste my time when you understand it's a fraction of a circle's circumference. All right, first one, it says find each arc length. Give answers in terms of pi and round it to the nearest hundredth. So when we're doing arc length, we're just going to write our formula down because every single time you have a formula, you're supposed to do what? Write the formula down. Certain person in this room who I've got, you're going to write the formula down? All right, okay. So with this one, what do we got? What is the fraction of the circumference I'm using? What's your degree measure, friends? Yep. So 134 over 360 times 2 times pi times my radius, which would be 8. So I get 134 over 360 times 16 pi. Now, what are you going to put in your calculator, guys? Because I want this in terms of pi and rounded to the nearest hundredth. So what's our fraction to start with? So 268 pi over 45 centimeters. Don't label, like guys, when I'm not paying attention, I will square when I don't mean to. So catch me on this if I do that, okay? Make sure I'm using the right measurements with it as well. So, and we're also going to do to the nearest hundredth, correct? What'd you guys get for the nearest hundredth? That's like 18.71 centimeters. I like what I heard. Good job, guys. Hopefully now you're getting to the point where you're just comfortable with working with formulas. And then realizing a lot of them just build on the previous information that we had. All right, have fun, guys. Go ahead and do the last two. Go ahead and do the last two. I'll stop you in a little bit. I'll just be working out here on the screen. And then you can use that as checks. So do the last two here for me. Always write down your formula. Don't be that person who doesn't. Bless you. All right, remember for these examples, you're supposed to do it in terms of pi and also the decimal for it. So give it to me both ways. Does anyone have B down? What'd you guys get for your fraction one? All right, awesome. Meters, right? All right, what'd you guys get for your decimal? That's kind of boring when you see it like that. 2.16. That just at least the fraction made it look big, right? All right, good stuff. 2.16 meters. How's the next one going? Would this one make sense to use the circumference, a different circumference formula? What do you guys think? Yeah, because I'm given diameter. Can I use pi times diameter? To me, it's easier. I just don't have less fractions I have to work with. So I get 135 over 360 pi times 11 over 1. That was really sloppy. What do we get? 33 pi over, I heard 8, right? And then centimeters. And what'd you get? I heard it, 12 point. Yep. What do you guys think? Not a bad day, is it? I would use this weekend to study for Tuesday's quiz. Just remember the quiz is over lessons 11.1 through 11.3, so just this week's stuff. So go back, work odd problems, memorize your theorems, terms, stuff that you guys love doing, you know. Make sure you have it. Also this weekend, stay safe and what? Out of trouble.